Alrighty, we are on 17.1c, which is right triangle trigonometry. So we are doing special triangles today. So you do not need a calculator today because you're going to have to memorize these special triangles. You may have even seen them already because you learned them in Math 2. And so we're just going to be practicing these so that we can put it all together. We can do SOHCAHTOA with these guys. We can find angles with these guys. We can do all kinds of things. And these are all things we do without a calculator. So the first two lessons of the chapter, we used a calculator because they were not special triangles. Once they are special triangles, no calculator needed. Woohoo! Okay. So, 30, 60, 90 triangle. You may have learned in Math 2 that when you have a 30, 60, 90 triangle, you get 1, and then opposite 60 is root 3, and then opposite 90 is 2. 1, root 3, hypotenuse 2. There used to be a cheer that we did in Math 2, but I don't know if they still do it. I don't know if they're cool or not. So, anywho, those do not look like these ratios, right? So opposite 30 degrees will always be 1/2. Opposite 60 degrees will always be root 3 over 2. And opposite our 90-degree angle is this nice clean 1. Do you guys see that? So how do we go from these to these right here? Well, as you progress in math, it's nicer and easier to work with if your hypotenuse is 1. So in this formula, the hypotenuse was 2. So if I want it to be 1, I need to divide it by 2, but I have to divide everything by 2. So now do you see how we went from 1 root 3 hypotenuse 2 to 1/2 root 3 over 2 and 2? Great. So you need to have those memorized. Opposite 30 is 1/2. Opposite 60 is root 3 over 2. Opposite 90 is 1. Okay? Next, the other special triangle. So you only have 2. That's not bad. Is 45, 45, 90. So in Math 2, you probably learned it as 1 square root 2. There's the other chant. But when you're looking here, we have a 45-degree angle, and its opposite is root 2 over 2, and then, opposite the other 45 is the same thing, because, you got to be the same if you're the same angle. But then opposite 90 degrees is 1, and you're like, okay, but those aren't those ratios. Guess what? If I want the hypotenuse or the radius to be 1, I have to divide everything by root 2. So now we have 1 over root 2, 1 over root 2, and this guy is 1, so that gives me that. But you're like, how is 1 over root 2 over 2? Well, in math, you're not allowed to leave irrational or radicals in the denominator. So in order to get rid of them, you rationalize them. 1 times root 2 is root 2. Square root of 2 times square root of 2 is the square root of 4, which simplifies to 2. So there's that. So you need to memorize that opposite 45-degree angles is root 2 over 2, and opposite 90-degree angles is 1. Okay? So look at that. For both triangles, the hypotenuse, or the radius is what we're also going to call it, is 1. So really, you only have 3 things you have to memorize. All right. This one says, fill in the missing sides of the triangle. Oh, 60 degrees. 60 degrees is a special triangle angle. So I know this is a special triangle. If I know it's a special triangle, I know the hypotenuse is 1. Opposite 60 degrees is always root 3 over 2. One easy way to memorize this what's 3 times 2? It's 6. 60 and 6. They both have 6's in them. I don't know. I'm just trying to help you out. We need to fill out the missing side. So if this is 60 degrees, that means that guy up there is 30 degrees, and always opposite 30 degrees is 1/2. So this is 1/2. Could you think of a way to memorize that? So when we did this, we did 3 times 2 is 6. What about this? 1 plus 2 is 3. So see if you can handle that. All right. We're going to go on to the next triangle. And now you can see we have our grid. I want you to write right here positive x, because this is the positive x-axis, negative x-axis. This is positive y-axis, and this is negative y-axis, right? So the reason why I want you to write that is because that comes into play. 60 degrees, oh my gosh, 60 degrees is part of a special triangle, so I know the hypotenuse is 1. Opposite 60 degrees is always root 3 over 2. The other missing angle is 30 degrees. Opposite 30 degrees is 1/2, but it's not positive 1/2 because I'm on the negative x-axis, so it's negative 1/2. Okay? Great. Not too bad at all. Okay, now here we are. We are at a 45-degree angle. So, oh my gosh, that's a 45-degree special triangle. So if it's a special triangle, the radius is 1. Opposite 45 degrees is always root 2 over 2. But remember, this is negative y-axis, positive y-axis. So you might be like, but Wilkin, we're not on the axis. But look, it just shifted over. So if I was like a point down here, what would be the coordinates? It would be negative x and negative y. So the length of the triangle, because it's below the x-axis, is going to be negative root 2 over 2. And again, this is negative x and this is positive x over here. Now, if that's 45 degrees, this has to be 45 degrees. And this is also negative root 2 over 2 because I'm in the negative x-axis. All right? Cool. Moving right along. Oh no, they're trying to trick us. Instead of giving us 60 degrees, they give us 30 degrees. But we are not tricked. We know it's 30, 60, 90 triangle. So we know this is a special triangle. So we know the radius is 1. It's opposite that right triangle always. Okay? So I am going to be smart, and I see that this is down here. So this is going to be negative, and I know this is going to be a positive value because it's on the positive x-axis. Okay? So what's opposite 30 degrees? Always 1/2. And if that's 30 degrees, this is 60 degrees, this is root 3 over 2. You will never have a root 3 over 2 and a root 2 over 2 in the same triangle. It's because they're corresponding to different angles, so you won't have that. All right? Okay, go ahead and flip it over. We are switching gears just a little bit. It says, draw and label the following angles. So, we have to start drawing angles now. So I want you guys to see, to start, this is 0 degrees right here. And then all the way over here is 180 degrees, like a semicircle, right? So this asks us to draw 180 degrees. So the way we show that we're going, you start at 0, and then you rotate to 180 degrees. So that's 180 degrees. So I'm going to check that off. I've done that. All right. Our next angle that I want to do is what if from 0 to 180 is here, halfway would be what angle? Let's do that one. That one's pretty easy. That would be 90 degrees. So I got this pink pen. This one right here is 90 degrees. Okay, you're like, okay, I get that. Okay, let's do the biggest angle that's on there. Let's get that out of the way. It says 360 degrees. So 360 degrees is one trip around the circle. So you start, you go all the way around, and you're kind of ending up right where you started from. And if you're in skateboarding or snowboarding or anything like that that requires turns, a 360 is when person does one complete revolution or one complete circle. If they only do a half, it's 180. You can actually keep going around this circle. So there's things called 720s where someone does two complete circles or two complete rotations. So we just did this guy right here. All right, so now 270. Where the heck would 270 be? Well, we already know that we have 90 and then 180. What is 180 plus another 90 degrees? That's actually 270 degrees. So right here, all the way to here, is 270 degrees. And you guys, math is so awesome. I know it's hard to see that pen, huh? Let's see if I can switch to this one instead. Guys, look at this. Math is so awesome. If you know your times tables of 9, 18, 27, 36, 45, look, 9, 18, 27, 36, and then you just add a 0. So easy. Okay, now we got to do these smaller angles. So we're going to start with the 45-degree angle. So if this is 90 degrees, 45 degrees is going to be exactly in the middle. So I'm drawing a big old angle because I could have drawn lines on there, but that angle right there is 45 degrees. Okay? You're like, all right, I get it. Not bad. What about the next one? Let's look at an angle of 30 and 60 degrees. So if we're here, this is 90 degrees. 1/3 of the way is 30 degrees, and 2/3 of the way is 60 degrees. Like, you literally cut it into 3 equal pieces. So here would be 30 degrees, and here would be 60 degrees. And so 60 degrees is going all the way to that guy right there. All right? So those are just some basic angles. You can graph angles that aren't ending in 0. You can do like a 22-degree angle. It's really hard to do exactly without a protractor. We're not using protractors, so it's okay. The reason why we need to be able to draw these angles is so that we can make our triangles and then evaluate using SOHCAHTOA. So that's this next problem right here. It says evaluate the following trigonometric expressions without using a calculator and with using SOHCAHTOA. So 30 degrees. So if this is 90 degrees, 1/3 of 90, so like right here. So once we draw our angle, here's the angle, we're going to drop down to the x-axis to make the triangle. Remember I told you we're going to be making these? Opposite 30 degrees is always 1/2, and we're in the positive y-axis and the positive x-axis, and the hypotenuse is 1. So I'm drawing this. It's asking me for the sine of 30 degrees. I know this is 60 degrees, but I'm not filling it in because this asked me for the sine of 30. So for the sine of 30, sine is opposite over hypotenuse. So I am going to do the sine of 30 degrees equals opposite over hypotenuse, which is opposite 30 degrees is 1/2 over a hypotenuse of 1. In math, you're not completely simplified until you only have one fraction bar. I have 1, 2. Lucky for us, this is why mathematicians did this. The hypotenuse is 1. 1/2 divided by 1 is just equal to 1/2. Okay? Next one says the cosine of 60 degrees. So we're going to draw a 60-degree angle. So this would be a 60-degree angle. You're going to drop it down. So this angle right here is 60 degrees. So 30 degrees is a little tiny angle. 60 degrees is a bigger angle. Hypotenuse is always 1. Opposite 60 is √3/2. Opposite that 30-degree angle that's up in the corner is 1/2. Okay? We're asked for the cosine. Cosine is adjacent over hypotenuse. So the cosine of 60 degrees equals adjacent over hypotenuse, which, what a coinky-dink, is 1/2 over 1. So that equals 1/2. It makes sense because our triangle has just been rotated. Okay? Almost done. We got tangent of 45 degrees. So let's draw that 45-degree angle. So 45 bisects that quadrant. So what do we know about 45-degree angles? You may not have this memorized yet, but √2/2 and √2/2. And the hypotenuse is always 1. tangent is opposite over adjacent. So we have the tangent of 45 degrees equals opposite over adjacent. Oh no. So we get root 2 over 2 is the opposite. I'm going to move my equal sign. Sorry, it's driving me bonkers. And adjacent is root 2 over 2. So if you're doing opposite over adjacent, you get this fraction. And there's 3 fraction bars, and we can't have 3 fraction bars in math, so how do we deal with that? So the way we deal with that is we either copy dot flip, or in this particular problem, any quantity divided by itself is equal to 1. So this one's just 1. Alright, our last problem for today is the tangent of 30 degrees. So step 1, draw your angle. Okay, so we're going to write steps. We're going to do them down here so everyone can see them. So 1, draw the angle properly. Step 2, make the triangle with the x-axis. Okay, so that was this part. Step 3, label your special triangle. With appropriate side ratios. Okay, so with appropriate. So here's where we are so far. This is a 30-degree angle, so we drew the angle, we made the triangle with the x-axis, and now opposite 30 degrees is 1/2, opposite that is the 60 degrees is root 3 over 2, and then 1, and then we have to now do the tangent of that angle. So our step is to calculate the trig ratio. So that's where you're going to use, so, whoa, keep doing that. SOHCAHTOA. Alright, so that's where you're going to do SOHCAHTOA, and in our case, in our problem, we're doing the TOA part, opposite over adjacent. So we have the tangent of 30 degrees equals opposite over adjacent, which equals 1/2 over root 3 over 2. Right? So how do we figure that out? Because it's not like this problem where it was a quantity divided by itself. We have to do copy dot flip. So what that looks like is you take the first fraction, which is 1/2, and then you copy it. And then you change this division bar, the main division bar, which lines up with that one, to multiplication, and then you flip this. And what you notice is these two quantities can cancel. So you get 1 over root 3. You're not allowed to have a square root in the denominator though, so you're going to rationalize, which is from the previous chapter, and you are going to simplify. 1 times radical 3 is radical 3, and any radical times itself just becomes that number. That's because this is really radical of 9, and the square root of 9 is 3. So that is root 3 over 3. Okay? So that's all it is for 17.1. We're done with 17.1. A, B, and C. Have a great day.